with the engine running, we will insert this in the tailpipe, and we are going to adjust for a maximum signal. And again, what we're looking for are these peaks. 1, 2, 3, 4. Run this again here. So we got it. 1, 2, 3, 4. We picked up a little bit of a fifth one. What we're looking for is that each of these is equal. This is all engines have a little valve overlap, or you have emission systems that are taking place in the pipe, but your concern is that each of these waveforms, this one shows a multiple, but it's the peak. You can count it. 1, 2, 3, 4, and you've got 4 lowers. 1, 2, 3, 4. And the fact that they're equal. If you have a point where you think you have something repeating or you're not sure, one of the tricks is to, again, put it back in mode and increase your time base so that you see 2 complete cycles of the engine, or 8 cylinders. Again, this vehicle has a fairly complex waveform. What we're looking for is there anything that's majorly missing or majorly different between any one of the waveforms. Some cars are absolutely smooth. You'll see a perfectly symmetrical waveform. Vehicles like this that have some of the older emission systems, you're going to see a more complex waveform. But what you're looking for is, if you do have a problem, is it repeatable from cylinder to cylinder? And what you can see here is that overall, this is a very good engine. You can go the other way with this also. If one has a trigger in place on the engine, one can go in and look at an individual cylinder. Right direction here. Wrong way. It's possible to pull an individual signature up on a cylinder. Now this is a 4-cylinder engine. Very little fuel is being burnt at this time, so you're not seeing a major input here for deviation in signal. And this is normal again for this type of engine. It's even more normal in some diesel engines. What we're going to do now is I'm going to have the unit held. I'm going to take the RPMs up, and we're going to see the increase in the output signal. Okay, we'll hold that for a second. We're going to take it up to about 1500 RPM. If you had an automatic transmission, it would be much better to do this with the vehicle in gear. This is a straight stick, so what we're going to do is just take the RPMs up to 1500, and we're going to show you how it maps on the scope. As you can see here, we've increased our signal. We're going to open our time base up. It's going to let us. We can't do it. So we're going to do this one more time. We'll have to do a little count on it. Here again, we can see that we have equal waveforms, 1, 2, 3, 4. Again, every vehicle is a little different. This one has a multiple peak because we have multiple valves, and the valves are staggered in their opening and closing sequences a little bit. So this is normal for this engine. Again, it's when it's majorly different. What we're looking for is a major expansion or contraction of the waveform. What we have done is we've gone into the engine and we have disabled one of the fuel injectors. At this point, you can see how before we had a nice even waveform. We're looking at a major fallout or a major change in the wave. This is, if we have a problem, this is how we identify it. And this leads us to where to start looking for a problem. In this case, we know we have something. Our compression was good. Our cold crank was good. We know everything in the engine was good. At this point, we have disabled an injector. Now, if we have a trigger on the engine off the number 1 cylinder, we could then identify specifically what cylinder that we would have to go look and go to work on the problem. Total time for a competent mechanic to do what we have just done, no more than 5 minutes. This is probably the best 5 minutes you would have spent working on a vehicle, because it's going to take you to the problem. It's going to get you working on the problem. There's many times that the OBD system will take you down a road that you think it's a component when it's actually the physical engine. This is the first step. It gets you into that point where you're understanding compression, valves, pistons. We're going back to basic engine 101 in high school. And once you know this is good, now you can believe your scan tool.